Welcome back everyone to Having Fun Repairs. This is Sean. If you recall, we left off on this AM-48 and we had to repair a trace on the PCB here, and we were able to get this item to finally power up and stay powered up. But we lost transmit, but we were getting receive, and that was working really good. So that's kind of a synopsis of where we left off. Now, there are some things I want to address from that previous video. When we tried the battery test, we were drawing 1.8 amps. That is a little bit high. So I want to, in this video, before we start troubleshooting any type of power issue, I want to see if our previous work on the board, if the amount of current drawn from our power supply has dropped down. So that's the first thing I'm going to do. And then if that's still high, then we may potentially have a short somewhere on the board, say a capacitor or something, maybe a bad in-channel MOSFET or rectifier, who knows. We can start troubleshooting power issues on the board, and that could explain why the relay is constantly clicking back and forth. If we have a faulty voltage regulator or something along those lines. Now, if there is no power issue, unfortunately, that means that I'm going to have to take this IC and this IC, probably back off these two ICs you see there, because here's the deal. When you have something that's very corroded, right, and even though we only found one trace at a time, or one trace at the time that was no longer making connection, well, we had to heat up the board with a heat gun. We had to reflow the solder, and every time you do that heating and cooling cycle, what happens to the PCB? Well, it's going to flex. Not a whole lot, but a little. And given the fact that those traces were very corroded, and I did what I could by putting some form of conformal coating over them, it's always a possibility that just through that heating and cooling cycle that more have gotten ruined. And if that be the case, then we have to do more trace repair. So that's kind of where my thoughts are going. Anyways, welcome back to this channel. Thank you for watching this video. If you have tuned in to watch it, we're going into part 2, and you know, like I said, and usually I leave this for the end of my videos. If you're looking for something repaired, go to my about section here on Google. It'll take you to my Google site. There's a form you can fill out and email me, and we can discuss what you need repaired from there. Please consider subscribing and like this video if you enjoy this content. Leave a comment in the comment section, and typically try to respond to as many as I can. That being said, I want to get into this device, at least first of all, here with a power up test on our DC power supply, and see what I'm getting as far as how much current's being drawn from our power supply. So I've already got this set up for 6.13 volts, slightly over 6 volts. I've got my current turned up. Let's turn this on. Okay, we have it powered up. Let's move it to, let's see. I said no audio. I do have this, let's see, monitor receive, monitor send, so that's in the center. I've got the volume all the way up. So we're still in the previous state that we were in. And I'm looking over here at my benchtop power supply, and we're only drawing 0.168 amps. So 168 milliamps, and that tells me that whatever was causing that quasi short before or whatever, that's 1.8 amps on 4 AA batteries. That is significantly high, but that's now been resolved. So I don't want to look at a power supply issue or anything in the power section just yet. I think we're going to be okay there, which means, unfortunately, it's time for me to take this thing back apart, take off those two ICs, and start troubleshooting them again. Now, versus me recording all that and speeding through it like I did last time, I'm just going to do this off camera, and if I find something, I'm going to come back to you. The one thing that I am slightly concerned about, given we had a lot of corrosion on our PCB underneath this IC and this IC right here, I don't know if this is focusing at all, we'll move it up for a second, is right around to the other side of that is what? The display. And we have elastomeric connectors underneath it, okay, or zebra connectors. What if corrosion got underneath there? Well, that means that I had to take this display off. And for those of you who ever mess with these LCD liquid crystal displays, when you remove an elastomeric connector that's been pressed against it for some time, it's always possible that the small layer of conductive film that's on the display will lift off with the elastomeric connector and potentially damage the display. It's also possible, given that this has probably never been lifted and removed, that if we do, I might have to replace the elastomeric connectors or zebra connectors. Hopefully that's not the case. Anyways, that's my rambling for now. I'm going to kill my power supply and take this apart, and if I find something, I'll come back and show you. Well, I have gone as much as I can without losing my mind over every inch. Traces after trace after trace concerning these ICs, and they all appear to be good. And I even went ahead and went as far as to remove the screen, even though I didn't want to, so I could go to the other side of the board and follow them throughout, and I'm not seeing any issues there. However, as I was working on tracing everything out, I did notice something else a bit odd. This time with our IC right here, you see HC015 or 0515-0-P-000 or 20H5C9535A. I haven't looked it up yet, but I imagine it's probably what's storing. It's either RAM or maybe it's logic gates, something. I'll have to look it up. Not too sure. Could also be the main confuser, but I highly doubt that as well. But I want to show you something that I saw while looking through here. Alright. I can't get this to zoom. Maybe I'll bring this down a bit. Looky right there, right at the foot of this pin. You see all that corrosion right there? And actually, as I started to try to peer underneath this IC, I began to see more issues. See, can I get that to focus in? Let's bring it down. There we go. And what are you seeing underneath there? See that white residue? More corrosion. Now, is this causing us an issue? I don't know. I'm even seeing a tad bit underneath these latches, these octals that we have sitting here and here. So I'm wondering if I just need to depopulate the entire side of the board over here and clean underneath this and see if there's any other damage. Underneath this IC here, Hold on a second. Move my microscope aside. Underneath this IC right here and these two ICs right here, I'll probably just depopulate those three and solder these back into place. So I'm going to go ahead and get these two back into place, and then I'll desolder these and we can take a look at them next. I've put everything back together because now with those ICs repopulated to the board, I just want to test it out to make sure that I haven't made anything worse. So I'm going to take this off of my ESD mat, just kind of elevate it. And let's put a 6-volt source from my DC power supply. I got it set to 6 volts, or honestly 6.07 volts. And let's turn it on to see if, make sure that we haven't made anything worse. Okay, still powers up. And we know receive was working. Let me switch over on transmit. Whoa. Wah wah wee wah wah. Would you look at that? Give me a second. I'll turn off my filter and then just serenade you with a nice 1 kHz tone. Okay, there we go. Transmit is now working. This is only a 2-layer board, so the topology would be components on top and then vias going through the board to the other side. Maybe I just didn't have those soldered on right, and resoldering them after cleaning up the pads and repairing that one trace got the transmit working again. I've got no way to change any buttons on it without doing a sweep. Got no way to change any buttons or anything without the keypad. But man, I don't know what to say about that. That's awesome. So I'll turn my filters back on. All right, so here's what I'm going to do instead. I'm still going to get a little bit of apple cider vinegar. No, not apple cider. What am I thinking? White vinegar in between here just to neutralize the battery acid underneath this IC. The corrosion that started forming there because of battery acid. Then I'm going to clean it out with some QD cleaner, some electronic cleaner. And then from there, reassemble it. And we'll test it out with my HP 4935 Alpha transmission test set. And just play around with it for a minute. Yeah, so let's do that. with the manual, actually let me cover this first. Put it back together, and then I used a bit of that white vinegar, as you saw if you caught it through the fast forwarded segment of this video, to clean out the corrosion. Sprayed it out with some QD electronic cleaner. We also touched up the battery terminals with my Drimmer tool to get rid of any residual corrosion after soaking it in white vinegar for several hours. Soldered everything back in, put everything back in, put it together, tested it with my benchtop power supply to the battery, to the terminals on the inside, and it powered up and it worked good. I don't have enough AA batteries right now, so I've got it plugged in through my DC power supply, and it's powering on just fine. So now we're going to do a functional test, okay? And we're given accuracy measurements right in our manual here. And I'll go through all these in more detail off camera, doing some testing, but we can do some simple testing here. One thing I do want to note is if you want to do anything above 10 dBm, if you want to transmit a level higher than 10 dBm, you must be set to 600 ohm impedance. This is something I always had to point out to trainees or students, and to even journeymen and a few craftsmen out in the field when I was teaching them how to set up this equipment. And then when you make noise measurements, okay, with an impedance of 600 ohms and your C message filter turned on, you must take this off of your DC or AC adapter, DC power supply, and you can only operate it on battery only. So if you're trying to see if you got any distortion or anything like that, noise on your 0 dBrn noise measurement function, and operate it on battery only, because the AC adapter, DC power supply, whatever, it does introduce about 6 dBrn even at quiet. Okay, so that's another thing to note. Now for our functional test here, even though it's given us our tolerances, neg 50 to 40, we have variances from 50 hertz to 20 hertz of plus or minus 0.8, plus or minus 0.3, plus or minus 0.5. From 40 to 10 dBm and 50 to 20 hertz. This is generator accuracy, right? So this is us sending out, okay? Variances of, or tolerances of plus or minus 0.5, 0.2, 0.3. For the receive side, it's pretty similar. On transmit, it looks like, or on receive coming in, tolerance of 0.5, same as that, 0.2 is that, but between the 15 kHz to 20 kHz tones, slightly wider tolerance, 0.5 versus 0.3. Same thing down here during the receive, 50 hertz to 200 hertz. We got the same tolerance between neg 65 dBm and neg 40, and slightly higher tolerance in between 200 hertz to 15 kHz, and then even a slightly more wider tolerance for receive, plus or minus 0.8 versus our transmit side. Okay, so right now I have my AM-48 set up for 0 dBm, 1004 hertz tone, and as you can see over here, this is receiving at neg 0.1, 1004 hertz tone. So we're getting pretty much what we're sending. All right, and again, I can't remember if I mentioned this in the video. If you're on 4-wire and you're using your RJ4011 4-wire plug, your send colors are green and red. Your receive colors, so audio back into here, are black and yellow. And the way I always taught this was Christmas trees and bumblebees. If you remember that, at Christmas you give gifts, and when you're outside playing, you get a sting if you're around bees. So transmit, receive. Anyways, so what I'm going to do is I'm just going to send this over to sweep, and we'll take a look. Actually, before I do that, here, hold on a second. Let me bring this back to 1004 hertz. If I turn up the volume, and I'll turn off my filters. Give me a second. Turn off noise suppression so that 1 kHz tone comes through. Alright, so I'm actually going to turn this down from here, and I want to listen to it from where I'm receiving. Alright, now we're going to put this on a sweep at 0 dBm. We're getting out of our audible listening range, so I can bump the volume back up. About 6 kHz, we start getting above that. I mean, 20 kHz, depending on how well your hearing is, you might be able to hear that. I don't know. Generally speaking, when you get older, your hearing goes out, but everything appears to be tracking. Our accuracy really hasn't gone outside of that plus or minus 2 range at 0 dBm on this sweep. Yeah, around 9 kHz and above, I start to lose my ability to hear the tones, definitely. Which is weird because I can't hear it over there at my other transmission test set, but as it's being picked up by my mic right here and an output to my headset on my head, I can hear the tones. I had a slight variation there of plus or minus 0.3. I'm not close to 15 kHz yet though. Above 15K is plus or minus 0.3. Yeah, we can see it's starting to hit that around 15K. Alright. I definitely can't hear anything now. Oh, I heard that. Yeah, I'm not hearing that though. Oh, heard a little bit there. Okay, well, let's set this at a different starting tone variance. Let's go to negative. What's the lowest? Neg 65. That's neg 40. It only allows me to go to the 50. Okay, that's fine. We'll do 50. Oh yeah, for transmit it's 50. Okay. Negative 50, and we'll start at let's start at 50 hertz. So the bottom of that range. That's only let me do 200 hertz. Maybe I got a setting wrong or something. 50 hertz. Only 200. That's fine. We'll just do 200. Okay. Neg 50, 200. And we can see we lose a bit of accuracy on our frequency. Could be because of my setup here, to be honest. I'm not going directly from a phono cable into here. So I could account for the variation, or maybe something internal to here or something internal to my HP test set. But we'll put it there, and then let's put it over to a sweep. Oh no, wrong one. Yeah. I would say that this is pretty accurate. I want to reverse this now. Let's get this out of here. And what we're going to do instead, let's put it on quiet. We're going to put this over to ABS and monitor receive. Okay. Which means I need to swap these around. Before I swap those around, I'm going to put this over into transmit. We're on monitor transmit now. Okay. And we'll do this in reverse now. Alright. I'll turn my volume down here. We'll turn our volume up here. Neg 10, 1004. We're a bit out of accuracy right here. Should be plus or minus 2. Whether that or not there's an adjustment in here for that, I'm pretty sure there is. I'd have to go through the manual to determine that, but simple fact is that we are getting a reading, and this right here, I know when I bought it, this guy over here, okay, I did very quick, you know, checks to see how the cow was, but so it could also be that this right here is a little bit off, not as accurate. Our output. I'm not sure if I can do a sweep function with this though. Yeah, I'm not seeing one. So I'll tell you what we'll do. We'll just step down from 1,000 to about 100 at a time. Should be able to get down to 50 hertz. It's 100 and we're 0.5. 0.8 is allowable below 200, so. Yeah, okay. I'm pretty happy with that. Let me step this back up again. Or no, 0.5 at 40 to 10. So, I mean, we're a little bit out of tolerance at neg 10. Turn this down. Alright, let's take our output down. What's as low as we can go on this? We need to at least get below neg 40. Go down to the very bottom of our scale. That's it. That's as low as I can go. Like 56.3. We got 55.7. That's too low for this guy to really measure. It's not picking up our tone. All right. So let's bring this up a bit to something that is usable. Like 46. So this would have a limited calibration unless if there's an adjustment for it. Okay. We're a bit more steady at -40. So I'm just going to do -45 or 43. Because we are bouncing, but we're pretty much there at 1004 hertz. And we'll run through and see what happens when we change frequencies again. No, you see as I drop down frequency, my amplitude drops. Can I go much lower? It's right there. Okay. 54 at 46. Yeah, this isn't even picking it up. It's too low. Definitely need limited cal. Occasionally I see that 54, but yeah, seems like the best range is not going below -30 dBm, at least at low frequencies. Let's see how it does on higher frequencies. We'll go let's see, we've already done 1000. Let's go above 15,000 hertz. And 29.6. Get this at 30. That's 9714, 9714. We're plus or minus 0.3. So slightly out of tolerance there. Let's keep going up. Oh, wrong way. There we go. We're above 15K. 30.1, 30.4. We're definitely in tolerance there. Plus or minus 0.5. So seems we get higher accuracy at higher frequencies, lower accuracy at lower frequencies, which I mean does make sense. So we're actually we're okay. This is usable for me in my lab. Barring these limitations that I'm seeing, and I hardly go that low anyways. If I wanted to go that at a low dBm value, I'd have a no kidding signal generator, and then even then I'm generating an RF carrier to modulate at say -97.5 dBm, or anywhere between -20 and then seeing if -102 and max AGC and then going up or something along those lines. But I mean, in my head, this is all right. From a non-working AM-48, which I'm pretty sure there are alignments in here. Self-inspection, self-test, power considerations, connectors, cables, and again, this is a very janky way of doing this test, so that can account for some of the inaccuracies that we're getting. I really need to go from what, 1/4 inch phono plug to, you know, or maybe 1/2 inch phono plug to 1/4 inch over on this side. You know, we got a little bit of signal radiation coming out here between these connectors. Anyways, or loss, that's probably what I should say. We do have in the instruction book operating instructions, circuit diagrams, impedance. So I want to say that I saw that at one point in time in the circuit diagrams, wherein, I see it's having us use a signal generator to do this test anyways. Okay. Where you can make adjustments internally. I think that was more towards the back. Yeah. You can take an oscilloscope. That's jitter. Where is it at? There goes a fold out. Glossary index. Service warranty. Here's the basic block diagram. That absolutely didn't do me much good at all with troubleshooting this. It does tell you that you got your microcontrollers and stuff to get your send or receive channel. You can see your amplifiers. This, again, very basic block diagram, providing you selection, detector dropped out, high gain hit detection. Your multiplexer sitting here, frequency counter. Of course, none of this would work at all without phase lock loop. Okay, that's the heartbeat of this entire device. If this isn't there, nothing works. Okay, so basically, you'd have nothing to bounce your counter off of without phase lock loop on, say, frequency synthesizer or CMOS chip, which is probably what that CMOS is for. Probably, or at least a part of. It's got to be somewhere in here. I'm pretty sure there are ways for us to make some measurements on the circuit board, and if not, then I'm just out of luck either way. And I'll just use this as a limited calibration piece of test equipment, which is still fine. I really have no use for anything above maybe 10 dBm, not below for negative 10 dBm, considering that this is an audio device. Yeah, I'm not seeing it right now. It is what it is. Anyways, that's going to kind of do it for this test. Hopefully you gathered something from it, and you know, just having a working AM-48 that was not working, transmit and receive, now functional, getting signal in from another test equipment item. And again, I don't know the state of every parameters on this transmission test set. Bought it off of eBay, and I kind of did a few tests and had it internally check itself. But beyond that, nothing else. But this seems to be working quite all right to me. Let's see, negative 5.5, 9.5. We got negative 9.7 here. It's 15,000 hertz, or 1514. I'll run through some more tests. Maybe take this back apart and play with some. I did see some trimmer caps in there, small potentiometers. I might play with them to see what that does, but I'm not going to arbitrarily just start turning things, because it could be voltage adjustments, or it could be something dealing with our phase lock loop, frequency counting, all that kind of stuff. And I don't want to change whatever internal oscillator is in there and get it off of the frequency it's oscillating at for phase lock loop, because when you do that, well, you've just destroyed your accuracy, because you've put in a variance of what is required for a phase lock loop to happen. But anyways, that's going to do it. I'm happy. This AM-48 is working again. We played with it for a little bit, and all it was battery acid underneath those ICs, which destroyed one trace. Of course, in the last video, my mess up resoldering it back on, but we took it back off, we cleaned everything up, heat soldered it back in, got a little rid of some more battery corrosion, and I have a personal transmission test set that I can include up on my bench of test equipment over here. So I'm happy. And yeah, and if you haven't noticed, right above my transmission test set, right above it, I got a new SIG-Gen because I blew it up in the last video, as well as a new new O-scope because I blew it the last one, and then a new arbitrary waveform generator over there, both signalant. This one is now 200 megahertz, slightly lower output on this the arbitrary waveform generator. I think the previous one I had was 60 megahertz. This one's 30, but it's a better build quality, so I'm happy with that. Anyways, that's going to do it for this video. I'm rambling at this point. Thank you for joining in to watch me close out this AM-48. If you enjoyed this video, please let me know in the comments section. If you're new to the channel, please consider subscribing, like this video, all that jazz and everything. If I can make any recommendations for anybody else who runs across an AM-48, I would focus on several things before you start tearing it down. If there is no corrosion or anything, the pins that go between board to board, make sure those are clean, and and then any input, make sure that those have been cleaned. Use any kind of electronic cleaning solvent. I use QD cleaner primarily when I'm cleaning out boards like this, and maybe that will bring back in some accuracy for you or some functionality. Beyond that, then you start tearing down and troubleshooting. But I'm rambling at this point, and I've already given you a closeout, so thank you for watching. Take care and goodbye.
Bark?